In this video, we'll be classifying shapes on a coordinate plane. So we'll either be given 3 points or 4 points, and you have to determine what kind of triangle or quadrilateral you have. So first we need to review our basic shapes. So if we're given 3 points, you have a triangle, but the question is, what kind of triangle do we have? Do we have equilateral triangle, isosceles triangle, scalene triangle, or a right triangle? So you know you have an equilateral triangle if all 3 sides are the same length. You know you have an isosceles triangle if 2 of the 3 sides have the same length. Scalene if none of the 3 sides have the same length. Now in addition, you also have to determine whether you have a right triangle. Okay, you could, for example, have a right isosceles triangle. Okay, and one of the interior angles could be 90 degrees. You can have a right scalene triangle, but what you cannot have is a right equilateral triangle, because the interior angles of an equilateral triangle is 60 degrees, because 180 degrees divided by 3 is 60 degrees. Okay, so classifying triangles is actually pretty straightforward, but I'd argue classifying quadrilaterals is a little more challenging. There are a few, well, yeah, there's quite a few more quadrilaterals we haven't written down here on this piece of paper. For example, there are kites, there are trapezoids. So we're going to talk about those later, but for this lesson, we're going to focus on square, rectangle, parallelogram, and rhombus. Now, if I were to be one of these quadrilaterals, I would be the square. The square is magnificent. The square is so beautiful and perfect. Okay. Now, of these 4 shapes, of these 4 quadrilaterals, which one is the least specific? It's the easiest to be this shape, and I would argue it's the parallelogram, because if you think about it, a rectangle is a parallelogram. A square is a parallelogram. A rhombus is a parallelogram. The conditions on being a parallelogram are the least strict. Okay, what does it take to be a parallelogram? Opposite sides are parallel to one another. And if opposite sides are parallel to one another, you'll notice that the opposite sides of the parallelogram also have the same length. Okay, so if an additional restriction is added such that, for example, the interior angles are 90 degrees, then you go from parallelogram to a special parallelogram, like a rectangle. Now, or you could also say, if we make all 4 sides the same length, you go from a special parallelogram, you go from a regular plain old parallelogram to a rhombus. Now, if you make both those conditions true, where the interior angles are 90 degrees and you make all 4 sides the same length, then you went from a plain old parallelogram to a very, very special parallelogram, the square. Okay, so if you have a quadrilateral and you have a rectangle, don't just say you have a parallelogram. You have to say you have a rectangle. Okay, so hopefully you can see the connection between square, rectangle, parallelogram, and rhombus, and the conditions that are placed in order to become one of these quadrilaterals. Okay, so you know what? Let's classify this triangle here for example 1. Okay, so I have points A, B, and C. Now on the test, if you feel more comfortable, what you can do is plot these 3 points, draw the triangle, and show yourself the shape on the coordinate plane. But for this lesson, I'm just going to jump into it, and I'm going to do the calculations. So I have to do the length calculations, and you might be wondering, do I have to do the slope calculations? And we'll mention that later on, but first I'm going to find the length of all 3 sides. Okay, so length of AB, you need to know your length formula. So rise squared plus run squared. Okay, so that's 2 squared is 4, 3, 9, 13. Alright, that's the length of AB. What about the length of BC? Alright, so it's going to be 5 minus 3 and 2 minus 5. And it's also root 13. Okay, so you know what? Right now, right off the bat, I can tell you it's either equilateral or isosceles. Once I find the third length, I will know the answer to that question. Length of AC, 5 minus 3, and 2 minus 5. Oops, it's AC, not BC. AC. AC, one more try. 5 minus 1, 2 minus 2. Okay, so that's just 4. Okay, so I can tell you right off the bat it's an isosceles triangle. Now what I can't tell you is whether we have a right isosceles triangle. Okay, so by the way, I know it's isosceles because 2 of the 3 sides are the same length. Now, is it a right triangle? So there's 2 ways to determine whether you have a right isosceles or just some regular isosceles triangle. You can do the slope calculations. Okay, so I'm going to go ahead do the slope calculations. Slope of AB. Now you can just use the rise and the run over here, right? 5 minus 2, 3 minus 1. So that's going to be 3 over 2, the slope of AB. Now the slope of BC, once again, you do the rise over run, so this is negative 3 over 2. And this one here, rise over run, you already know it's 0. So 2 minus 2 over 5 minus 1, which is 0. Okay, so now that I've done the slope calculations, I can tell you that triangle ABC is not a right triangle because I'm looking at the slopes. None of them are reciprocals of each other. Okay, I studied the 3 slopes, so no negative reciprocals, which means the adjacent sides are not perpendicular to each other, so I have no right angle. So yeah, obviously it's not a right triangle. Instead of calculating slopes, because doing 3 slope calculations is not the quickest thing, so what I can do to check whether I have right triangle, what I can do is check if the Pythagorean theorem is true, right? Because if it is indeed a right triangle, guess what? A squared plus b squared equals c squared, right? If it is a right triangle, the Pythagorean theorem must be true. So instead of doing the slope calculation, I can do a Pythagorean theorem calculation. So which one, if one of these sides were to be the hypotenuse, it would be AC because it's the longest side. So what I'm going to do is check, right? If the Pythagorean theorem states a squared plus b squared equals c squared. So if c is equal to the square root of a squared plus b squared, then it's a right triangle. So we're going to check, okay? So we're going to check whether that is the case. So this is root 13 squared, and that's going to be 13 plus 13 is 20, the square root of 26. So is this equal to 4? No, this is not equal to AC. Okay, so since this is the case, then I know I don't have a right isosceles triangle. I just have an isosceles triangle. So what you should do is, since this is saying 2 of the 3 sides are the same length, and I'm going to say the Pythagorean theorem is not true. Oops. The Pythagorean theorem is not true. Therefore, triangle ABC is isosceles. Okay? Alright, so let's do the next example. We're basically going to classify a quadrilateral. Alright, the same idea. So instead of 3 points, you have 4 points. Really not much to say. But just like last time, if you really feel uncomfortable doing these questions, plot the 4 points and give yourself a visual aid, okay? So, quadrilateral ABCD. I have 4 length calculations and 4 slope calculations. I am not looking forward to that. So you know what? We can actually get away with doing a little less. So I'm going to cheat a little. Well, not cheat, but I'm going to apply a little shortcut. So slope of AB, 5 minus 2 over 5 minus 1, 3/4. Slope of BC is going to be 5 minus 5, 10 minus 5, which is 0. Slope of CD is 2 minus 5 over 6 minus 10. So that's going to be 3/4 again. Slope of AD will be 2 minus 2 over 6 minus 1, which is 0. Okay, so let's take a look at our slopes here. So I can tell you I definitely have a parallelogram because opposite sides are parallel to one another. So slope of AB is 3/4, slope of CD is 3/4, so same slope, parallel. And same could be said for BC and AD. They have the same slope, they're parallel to each other. So I definitely have a parallelogram. Opposite sides are parallel to one another. But what I don't have is a square or a rectangle because I'm looking at the adjacent sides, AB and BC, their slopes are not negative reciprocals. So I don't have a square, I don't have a rectangle. Now the question is, do I have a rhombus? Or do I have a plain old parallelogram? Nothing special about it. So in order to check whether I have a rhombus, I need to check if all 4 sides are the same length. Now, am I going to do 4 length calculations? Well, it would be nice if I can get away with doing less. So let's see by solving for length of AB. Okay, so I have the rise and the run here, so that's nice. Right here. So that's 4, 3, that's 5. Okay, so you know what? I feel like we actually can get away with doing just 2 length calculations. It makes sense, right? Because I know I have a parallelogram. I have a parallelogram. And what do you know about parallelograms? Well, let's take a look at this beautiful parallelogram. Opposite sides are the same length. So you know, let's label the endpoints here. So, the vertices, sorry. So if I know the length of AB is 5 units, then can we not say the length of CD must also be 5 units because it's a parallelogram, right? So by doing this calculation, this length calculation, I don't need to do this length calculation. If I know the length of BC, I don't need to do another length calculation and find the length of AD. I already know I have a parallelogram, right? So once I'm done the calculation for the length of AB and the length of BC, I'm done. Time to go. All right, there's no need to progress here. No need to continue doing more calculations, okay? Now there's actually another way around it. What you can do is do 4 length calculations and then 2 slope calculations, okay? Because if you do 4 length calculations, you'll basically tell yourself you have a parallelogram, and then you have to check whether you have a rectangle sorry, one more time. If you do the 4 length calculations, you'll realize you have a square or rhombus. And once you do the 2 slope calculations, you'll identify that you actually have a rhombus and not a square because these slopes are not negative reciprocals to each other. Just a side point. If this angle here, let's say, is 90 degrees, then the other 3 angles must be 90 degrees as well based on what you learned in grade 9. This is a C pattern here. So co-interior angles, they add up to, they're supplementary. So this is 90, then this must be 90. And then you can see another C pattern, which means this is 90. Another C pattern, this is 90. So there's lots of ways to prove that all the angles are 90, but once you know one of them is 90, the rest must be 90 if you have a parallelogram. Okay, so let's summarize those ideas here. How do I know I have a rhombus? Okay, that's really important. You have to tell the reader. So you tell the reader that the slope of AB is equal to the slope of CD. The slope of BC is equal to the slope of AD. You should also tell the reader that adjacent sides are not perpendicular, which means the interior angle is not 90 degrees. And lastly, you should say that the length of AB is equal to the length of BC. Okay? Therefore, quadrilateral ABCD is a rhombus. Okay, so that's how you classify triangles and quadrilaterals. If you have a triangle, you have to remember to make sure to determine whether you have a right triangle or not. So you can either use the slope calculations or the Pythagorean theorem. If you have a quadrilateral, here's a shortcut. You do the 4 slope calculations and then 2 length calculations. But if you really love the length calculation, then do 4 length calculations and 2 slope calculations. Okay, so hopefully now you're good with classifying shapes on a coordinate plane.